Hello students, welcome to your chemistry class. Actually I was little sick, that's why I have unable to send the videos. Sorry for that. So we were reading about the first chapter, that is periodic table and its variations along the period and down a group. So let us continue that. Still this is your third video. In the second video we have discussed about two properties and their variations both along the period and down a group. The remaining properties today we are going to read. So let us start. So here you can see we have completed this one in the last class, that is the atomic size and your number of cells. So next one, what is the, let us see. So we'll start from your metallic character. So this is the common thing that metals only will show the metallic character and non-metal will not show. So just for simple you can understand simply that metals, they show the metallic character, and you know how to know one element is metal or non-metal. You have to check about their valence electron and you have to check whether they are losing or gaining. If they are losing and their valence electron is 1 to 3, then they are the metals and they must produce the cation. Then only they show the metallic character. So here it is written, see, those elements which have a tendency to lose the valence electron and form a positive ion, they are considered as metals and they only shows the metallic character. So sodium and magnesium one, it is example given, you can see. Sodium here it is losing 1 electron and forming the sodium cation. Magnesium it is forming it is losing the 2 electron and forming the magnesium cation. So here you can see sodium is having 1 electron and magnesium is having 2 electron, and this way they are the metals and they form the, they show the metallic character. So dear students, every time wherever you are trying to write the variations of the properties both in the along the period and down a group, at that time you have to keep in your mind about these two things only, that is your atomic size and nuclear charge. If you have understood these two clearly, then whatever the variation wherever that group or period you can write correctly. With this another term you have to, and their variation you should know, that is your number of cells and your valence electron. If you know this four, then easily you can write all the variations of all the properties. So let us see how it impacts the properties. So here one note it is given, I think you know this one. Hydrogen is an element which doesn't have a neutron. It has only 1 electron and 1 proton. On losing this electron, it forms its cation, which has only 1 proton. That's why it can be also called your proton. But whereas the other elements, when they form the cation, at that time in their atoms both the proton and neutron will be there. So what is atomic size and what is your nuclear charge you have already read, but how it impacts your, how it affects your metallic character, on the basis of that we have to see now. So if the atomic size it will be more and your atomic radius will be more, then the nuclear cannot attract easily the electrons. If the nucleus cannot easily attract the electron, that means nuclear charge is less, and if the nucleus cannot attract, then the atom can easily lose the electron. That's what it is happening in case of every elements. As the number atomic size is more and the electrons are far from the nucleus, that's why they easily lose the electron, and that's why they are the metal and they show the metallic character. That's what it is written. You can read your own. Next you see nuclear charge. I think about the nuclear charge also I told you that if the nuclear charge will be greater, then the greater is the force exerted by the nucleus on the electron of the outermost orbit, and this one only it will difficult to remove the electron from the outermost orbit, and the metallic nature decreases. This is about the your non-metals. Here it is written how your metallic nature decreases. How can you relate with the atomic size? If the size is less, the electrons are very closer to the nucleus, and nucleus will always try to hold the electrons and it will try to attract towards itself. Then the outermost electrons, they cannot move from there, and maximum electrons will be there in the outermost orbit, and as they are unable to lose their electron, that's why they form the non-metallic character, or you can say they always try to gain only. As their nuclear charge is more, so they will always want to gain the electrons, and they are the non-metals and they form the non-metallic character. So all of you just see table 1.2. okay, variation we will read later on. First you see this table first. This is group 1 to group 18. It is given group 1 to group 18. So you just see the valence electrons everywhere, 1 2 3 4, and it is increasing only. Now you see the metallic and non-metallic your character. So by looking this table, we can say the elements having 1 2 3 valence electrons, they are the metals. I mean, they are showing the metallic character because the nuclear charge is less, the distance is more between the electron and the nucleus, so easily they can lose, and that's why they are the metals. So you can see here, these are the metals, and the middle one is metalloid. What is metalloid? You have read in your lower class also. Metalloid means these are the substance which shows the characteristics of both your metals and non-metals. And how can you know whether that is metalloid or metal or non-metal? Just simple formula I have told you. 1 2 3, if the valence electron is there, then that is your metal. If the valence electron is 5 6 7, then that is non-metal. If the valence electron is 4, then that is your metalloid. Then you see this side, these are your non-metals. You can see the valence electron, that is 5 6 and 7, and 8 means that is your noble gas, no? So no need to see that side. I hope you have understood about the metallic character and non-metallic character. Now let us see your across a period. You know, across a period, the atomic size, it decreases, and atomic size decreases means in the beginning the metallic nature or the metallic character will be there, but slowly it will be goes on decreasing. That means the non-metallic character will be improving. So see, on moving across a period, nuclear pull increases. Yes, because the atomic size is decreasing. As the electrons are more and the distance is less between your valence electron and your nucleus, that's why the size is increasing and nuclear charge is increasing. That's why it is written, on moving across a period, nuclear pull increases due to the increase in atomic number, and the atomic size decreases. Hence element cannot lose electrons, because as the your atomic number is increasing, means your valence electron also will increase. So more valence electron means instead of losing, it will gain to get stable. As the nuclear charge is more, so it cannot lose the electron. So therefore the metallic nature decreases across a period, moving from left to right. So you see, so small example it is given: metals, lithium and beryllium. Boron is your metalloid, then carbon, nitrogen, oxygen your non-metals. And so here you can say which one is the most metallic, that is your lithium, because in across a period, that is from moving from left to right, metallic character decreases, no? The first one will have the most metallic one. Next, after that, about the group it is given. So you know, down a group your atomic size increases. Atomic size increases means your nuclear charge decreases, and like this way your atomic size is increasing. Sorry, I think I have said that down a group your atomic size increases, so it will increase. Okay, I think I have said decreases. Sorry, down a group your atomic size increases and nuclear charge decreases. And atomic size is more means the element can easily lose the electron. So if you will see the variation, see it is group 1 from lithium it is given. So lithium will be your least metallic and cesium will be most metallic, because down a group, just now we have discussed, down a group your atomic size is more. Size is more means easily it can lose the electrons, and that's why the down one is the completely strongest metal, you can say. So metallic nature increases as one moves down a group. So you have to read this one, what is written there. Next we will read about the non-metallic character. How to recognize the non-metals, many times I have told. Once again I am saying, the elements which have a tendency to gain electrons in order to get stable or to attain its octet in their outermost orbit, they are called the non-metals, or simply you can say the elements which is having 5, 6, 7 electrons in their valence shell, and they can gain 3 or 2 or 1 according to their need. They are called your non-metals. And so non-metals, they are not going to lose, they are going to gain the electrons, and after that they form the anion. Here one example it is given, you see, chlorine 1 it is given. Chlorine, you can see 7 valence electron it is having, and it will gain one electron and it will form the chlorine anion. Like that your nitrogen, oxygen, sulfur, phosphorus. Okay. So now just for few seconds you pause the video and try to say yourself the variation of non-metallic character across a period and down a group. I hope everyone will able to answer this. So see here also atomic size and nuclear charge it is given. You read that one your own. So see the trends or the variation of non-metallic character. So just now I told you, down a group your atomic size is more, nuclear charge is less, and the metallic character increases. Metallic character increases means that is opposite of your non-metallic character, means non-metallic character will decrease. Okay, metallic character will increase, non-metallic character will decrease. Just see group 14 it is given, from carbon to your Pb it is given. Just see, carbon is the non-metal, then 2 metalloids are there, again then metal is there, means non-metallic character it is decreasing, means from the non-metals to we are going towards the metals. So atomic size increases, addition of new cells over successive periods, and the nuclear charge increases due to increase in atomic number. Effect of increasing atomic size is greater. It is written the same I told. Now let us see across the period left to right. So you know across a period your atomic size decreases and your nuclear charge increases. So what happens about the non-metallic character? As the atomic size decreases, so your non-metallic character it is increases and your metallic character it is decreases. After watching this video, once again you read what is given in your book. Clearly you can understand. One example it is given, you see. From sodium to chlorine it is given. Sodium to aluminum, they are the metals and they are showing the metallic character, and phosphorus to chlorine they are showing the non-metallic character, and they are the non-metals. Then we will see your chemical reactivity. So what is your chemical reactivity? Chemical reactivity means it depends upon their tendency to lose or gain electrons to complete their your outermost orbit, or to get stable. How much or how many electrons they are losing or gaining, that is only your reactivity. If their tendency is greater for losing the electron, then their reactivity is greater or is more in case of the metals. If the tendency to gain electrons is more, then in that non-metal the tendency is greater. Just simple means, simply you can say, if the more chances are there to lose the electron, then that metal is having the greater reactivity. If the non-metal's chance is more to gain, then that non-metal is having greater reactivity or stronger reactivity character. So let us see the trends in the chemical reactivity. On moving from left to right in a period, the chemical reactivity of elements first decreases and then increases. Why it is happening? See, in the periodic table, maximum are first it will decrease, then after that it increase, or maybe it increasing, after that it decreasing, because first the metals are there, then metalloids are there, then your non-metals are there. So let me show you the periodic table. So see, here the metals are there, then your metalloids are there, then your non-metals are there. That's why your reactivity first it will increase, then it will decrease. Okay, and moving from left to right, the chemical reactivity element first decreases and then increases. So first see, group 1 we will discuss. Group 1 element can lose their electrons easily as compared to group 2. Similarly, group 2 elements can also lose the electrons easily, but in comparison of group 13, they will not same as your group 1. The tendency to lose the electrons it decreases, means their tendency to gain the electrons increases in case of your group 13. Okay. See, silicon is the least reactive element in the third period. As we move from phosphorus to chlorine, the tendency to gain electron increases and reactivity again increases. Simply nothing is there, you see. First, the reactivity it is decreasing, then completely least reactive is silicon one, then from, let me clear you, from left to right it will decrease, means most reactive is your sodium one. Okay, silicon one is least reactive. Then from right hand side to left hand, right to left, this side if you will see, chlorine is the most reactive non-metal and your silicon is the least one, because I have told you reactivity means what, strong reactivity means what, which metal is have the more tendency to lose the electron, that is having the strong reactivity nature, and which non-metal is having to more chances of gaining the electron, that is having the most reactive non-metallic character. the same in donor group. So we will see the example. Before that, what happens donor group, let us see. The tendency of losing electrons increases down the group, and the chemical reactivity in metals depends upon the tendency to lose the electrons, and thus its reactivity increases on going down the group. Simply you can see on basis of the metals and non-metallic character also. Okay, as the as the atomic size increases down a group and the metallic character also increases down a group, so easily, so the tendency of losing electrons, it increases down the group. Okay, and the chemical reactivity also in the metal, it will increase, that is down a group. So the most reactive metal is at the bottom of group 1. The chemical reactivity, the other case, if you will see the non-metals one, the non-metals decreases on going down the group, and it depends upon the tendency to gain electrons, and the most reactive non-metal will be your fluorine. So let me show you these two elements in the periodic table. So see, fluorine is here, fluorine is here, and just now I have told you the most reactive metals will be and non-metals will be on the top of the periodic table. So this side your metals and this side your non-metals. The top one, they are called the high reactive metals and non-metals. Okay, next one, let us see the variation or the gradation of the physical properties. You know, the metals are soft and the non-metals are hard maximum time. So obviously the metals will have, they have the low melting and boiling point, and you know, down a group your metallic character increases. I mean, metals are more there down a group. Okay, so the melting and boiling point of the metals decreases on going down the group. So see, it is given some melting and boiling point of your lithium, sodium and potassium, it is given, and it is decreasing also if you will see the value. What about the non-metals? Their one, it increases. See, fluorine, chlorine, bromine, your iodine one, it is given, and it is increasing. Why it is increasing? Because down a group the metallic character is increasing, means the non-metallic character is yes, the non-metallic character, it is decreasing down a group. That's why their melting and boiling point of non-metals, it increases down the group. Next, let us see what happens across a period. Left to right, melting point and boiling point usually increases, because you know atomic size your decreases. Okay, and your metallic nature decreases. That's why your melting and boiling point increases. I mean, from the soft to they are converting into your solids, you can see. It increases up to group 14 and then it decreases. Third period, one example it is given. Then density of elements across a period increases gradually to maximum and then slightly decreases, may be noticed, you can see here. And what about the density down a group? That one increases gradually. Okay, so for today this much only, students. In your last class also some questions were there. I hope everyone has tried to solve it. If anything doubt is there, then in the online class we'll have, after this completion of the chapter, we'll have the online class. There you can ask the doubt. So this is for today also, one task is there. These questions you have to solve, and the doubts one we will discuss in your online class. Okay, next mode, I think 3 properties left, that is ionization potential, affinity, negativity, this much only, and we'll read atomic number must know. After that this chapter will be covered. Okay, so thank you for today's class.